4, differential equation, Newton's law of cooling. So this is the other example of problem that involve temperature, and we can solve by using the first order differential equation. Okay, previously we have learned two examples of first order differential equation involve population growth and radioactive decay. So this is the Newton's law of cooling. So the formula we will use in this chapter is this one. Okay, so example involve in the medical examiner to find the time of this of homicide case, or a chemist can determine the time required for plastic mixture to cooling a hardening temperature. Okay, an engineer can design the cooling and heating system of a manufacturing facility. So Newton's law of cooling, the rate at which the temperature T can change in a cooling body at time T is proportional to the difference between the temperature of body and the constant temperature Tm between the surrounding medium. Okay, then the formula for the Newton's law of cooling can be divided as follows. So this is the formula of the temperature. dt over dt is equal to negative k T minus T naught, where T naught is equal to surrounding temperature. So T is the temperature of the body, or we can write down in the formula of 1 over T minus T naught dt is equal to negative K dt. Then after we separate dt at our left hand side and another one aside d small dt at our right hand side, then we integrate both right and left hand side, we will get ln T minus T naught equal to negative KT plus C. Okay, then when we cancel ln, we need to multiply both side by exponential, then we will get T minus T naught equal to e power of negative KT plus C. Then T minus T naught is equal to e power of negative KT times e power of C. And when our A is equal to e power of C, we will get T minus T naught equal to AE power of negative KT. Okay, negative sign, negative of negative K here means indicates the decreasing of temperature. So let me solve this example. Okay, so for the first example, we have an investigator found a dead body lying in a hotel room at 5:45 p.m. The temperature of this body was taken and it was found to be the room temperature was we have the value here was 82 degree Fahrenheit. Okay, the temperature of the body was taken again at 11:45 p.m. and it should find the time of the death. The normal body is 98.6 degree. So okay, so for this case, first of all, what we need to do when we get a question, we need to solve for the dt over dt. Okay, this is the basic formula for temperature. D capital T over d smallest t is equal to negative k times T minus T naught. And then we solve dt over T minus T naught is equal to integration of negative k dt. Okay, then we will get ln T minus T naught is equal to negative KT plus C. Okay, then when we cancel ln, we will get T minus T naught equal to e power of negative KT times with e power of C, and A is e power of C, then we will get t minus t naught is equal to a e power of negative kt. So for this case, if we look at here at 4:45 p.m. Okay, so this is means but t is equal to 0 and our temperature is equal to 82 degree Fahrenheit and t naught is equal to 55, the room temperature. Sorry, I was found to be okay. Sorry, this one is 82 degree Fahrenheit. Okay, this one is degree Fahrenheit, 82 degree Fahrenheit. Okay, this one is 55 degree Fahrenheit. Okay, so our T naught is the room of temperature, which is 55 degree Fahrenheit. Okay, so from here we can find the value of A, okay, by using T minus T naught. So our T is equal to 82 minus with our T naught. T naught is 55 is equal to A e power of negative k times 0. Okay, so we will solve here. We will get our A is equal to 27. So T minus 55 is equal to 27 e power of negative kt. Okay, so this is the formula we will get from our first example. Okay, next we look at our second. At 11:45 p.m. okay, means T is equal to 2. Okay, 2 why? Because we minus 11:45 minus with 9:45, there we will get equal to 2 here. Okay, so when our T is equal to 2, our capital T is equal to 73. Okay, so this one have 73 degree Fahrenheit. So there are missing number there. Okay, so we just plug in 73 minus with 55 is equal to 27 e power of negative k times with 2, and then we will get our k here, negative 2k. So k is equal to ln 18 over 27 over negative 2. So we will get here our k is equal to 0.2020 0.2027. Okay, so T from here we will get T minus with 55 is equal to 27 e power of negative 0.2027 T. And then the last question, time of date, we need to know what PM. Okay, what PM, T is equal to what PM. Okay, how many hours? Okay, how many hours to make our T is equal to 98. Normal body is 98.6 degree Fahrenheit. Okay, so what we need to do here is we just plug all the formula. Okay, so we already know here T minus 55 is equal to 27. Okay, our T now becomes 98.6 minus 55 is equal to 27 e power of negative 0.2027 T. So from here we will get the value of T, which is T equal to ln 43.6 over 27 over negative 0.2027, and after solve we will get our t is equal to negative 2.36 for 2 hours. So it means we need to multiply with 60 in order to change to minutes. Okay, so we multiply this by 60 and then we get in minutes. So in minutes we will get 21.852 or equivalent to 22 minutes. Okay, so 2.3642, it means that we have, okay, this one for, no, 21. Okay, time of day is actually we convert from hours to minutes. Okay, so from hours to minutes we will get 2.3 642 is actually 2 hours 22 minutes. Okay, so I write down time of date here. So time of date is actually 9:45 p.m. minus with 2 hours 22 minutes. So it's actually equal to 7:23 p.m. Okay, next we look at the example 2, a thermometer that reads 80 this thermometer that reads 90 degrees Celsius is placed in a room with a temperature of 70 here. Okay, 70 degrees Celsius. After 3 minutes, the thermometer radius reads 80 here. Okay, so what is the thermometer read after 5 minutes? Okay, so the first time, as usual, we need to come up with the formula for temperature. So dt over dt is equal to negative k t minus t naught. Okay, so dt over t minus t naught is equal to negative k dt. Okay, so ln t minus t naught is equal to negative kt plus c. Then at the end we will get t minus t naught is equal to a e power of negative kt. Okay, or our t is equal to a e power of negative kt plus t naught. Okay, so when our t is 0, when our t is 0, okay, the temperature is 90. This is the first equation. So t naught is equal to 70. Okay, so 90 is equal to a e power of negative k times 0 plus with 70. Okay, this is our first equation. Our second equation is T3 is equal to, after 3 minutes, temperature is 80. So T3 equal to 80. So we solve, we will get 80 is equal to AE power of negative K times 3 equal to plus with 70. We solve, we will get our E Our K is equal to, our K is actually equal to ln K. We will get from here K. K here. We will get this one. We will get our K is equal to ln K. 80 minus 70 is 10. 10 over K. A here. Okay, we will get A here. A equal to 90 minus 70 equal to 20. So 10 over 20 over negative 3. Then we will get our K is equal to 0.2310. Okay, so from here we substitute our A and our K. We will get the value of T here is equal to 20 e power of negative 0.2310 T plus with 7T. Okay, and at T equal to 5, so T equal to 5, what is the value of T? Capital T. So T is equal to 10T e power of negative 0.2310 times with 5 plus with 7T. So we will get T is equal to 76.30%, 30 degree Celsius. Okay, let me try to solve example 2b here. So suppose that the temperature of a cup of coffee obeys Newton's law of cooling. If the coffee has a temperature of 100 degree when the freshly poured and 1 minute later has cooled to 98.7 degrees Celsius in the room 37.7 degrees Celsius. So determine the coffee reached at a temperature 75 degrees Celsius. Okay, so first of all, we need to solve the integration of dt over t minus t naught. dt is equal to integration of negative k dt. So from here, we will get our ln integration of t minus t naught equal to negative kt plus c. So our t minus t naught is equal to a e power of negative kt, or our t is equal to a e power of negative kt plus with t naught. So t0 is equal to 100. Okay, t naught is equal to 37.7 degrees Celsius, and 100 is equal to a e power of negative k times 0 plus with 37.7. So from here we will get our a is equal to 62.3. Then our t is equal to 62.3 e power of negative kt plus with 37.7. Okay, so from here we will get 98.7 0.62.3 e power of negative kt. Okay, kt, sorry, this one when our 1 minute later, so it could 98.7. So 98.7 when t is equal to 98.7, so t is equal to 1. So 98.7 is equal to 62.3 negative k power of negative k is what we want to find here. So means we already know the value of t here, which is negative k times dengan t1 plus dengan 37.7. Okay, so from here we will get our k is equal to ln 61 over 62.3 over negative 1. So K equal to 0.0211. Okay, then we will get our T is equal to 62.3 E power of negative 0.021090 plus 37.7. Okay, so at T is equal to what? Then capital T is equal to 75. So 75 is equal to 62.3 E power of negative 0.021090 plus with 37.7. Then we solve, we will get our T is equal to ln modulus 37.3 over 62.3 over 0.0211. So equal to 24.43 years. Okay, let me try to solve. Okay, this exercise you can do by your own. Then we look at mixture problem. So in the mixture problem, this is the example of application using fluids in a tank. Okay, so the input rate will equal to the rate of fluid containing the substance flows into the tank times the concentration of substance in fluid as follows. So the rates of N is equal to concentration times dengan inflow rate. Then the output rate is equal to the exit rate of fluids in the tank times the concentration of in a mixture. So rate of output is equal to the amount PT of original amount of substance plus inflow rate minus outflow rate times T times outflow rate. Steps: determine the input rate and output rate using the given information. Substitute into the formula of dP over dt is equal to rate in minus rate out. Then we solve the linear differential equation by using the first need to find the integrating factor, multiply both sides with the integrating factor, and then we solve for the P to get the expression of the problem. So this is the step how to solve the mixture problem. Okay, let we look at the exercise example 1. In a tank initial contents of 100 liter. Okay, let we highlight all the point given here. Okay, 100 liter of blend in which 20 grams of salt is dissolved. Then water containing 2 grams of a salt per liter is poured into the tank at a rate of 1 liter per minute, and the mixture is allowed to leave the same rate. Find the expression for the number of grams of salt in the tank at any time t, and the amount of salt in the tank at the end of 30 minutes. Okay, so first step what we need to do is step 1. Okay, we need to find the rate. Okay, the rate in. Okay, the rate in is equal to 2 times 1. Okay, 2 times 1 because of 2 gram and 1 liter per minute. 2 times 1, then we will get 2 here. Okay, then this is rate in. And rate out is equal to P over 100. Okay, 100 take from this plus 1 minus 1 times T times 1. Then we solve, we will get P over 100. Okay, step number 2. We substitute into the formula. Substitute into the formula. Okay, so dP over dt is equal to rate in minus with rate out. So is equal to 2 minus with P over 100. Okay, then we will get dP over dt plus P over 100 is equal to 2. Then step number 3. Okay, step number 3, solve the dP over dt plus dengan P over 100 is equal to 2. Okay, by using IF, integrating factor. So E power of integration 1 over 100 dt is equal integration of 1 over 100t plus with C. So we solve for this one, we will get equal to AE power of 0.01 t. So from here we substitute AE power of 0.01 t times with dP over dt plus with P over 100 equal to AE power of 0.01 t times 2. Okay, then PE power of 0.01 t is equal to 2E power of 0.01 t. So integrate this one at our right hand side dt. Okay, then we solve, we will get 2E power of 0.01 t over 0.01 plus C, and by substitute our t is equal to 30. Okay, when our t is equal to 30, then we will get our P is equal to 200. C is equal to 200 over E power of 0.01 t. Okay, let me look at next example. Okay, a large tent holds 100 gallons of fruits in which 10 pounds of salt is dissolved. Okay, so that we highlight all the value given here. 100. Okay, then fresh blend of concentration half a pound of salt per gallon is pumped into the tank at the rate of 6 gallons per minute. The well-mixed solution is then pumped out a slower rate of 4 gallons per minute. Find the amount of salt in the tank after half hour. The capacity of the tank is 250 gallons. So how long it will take for the tank to fill up? Okay, so for number A, dP over dt is equal to R in minus with R out. So equal to 3 minus with 2A over 50 plus T. So dP over dt is equal plus with 2A over 50 plus T is equal to 2. So by using IF, equal to integration E power of 2 over 50 plus with T dt, then we will get E power of ln 50 plus with T power of 2, or when we cancel ln and exponential, we will get this one is equal to 50 plus T power of 2. Okay, so we multiply IF multiply with the equation, which is equation of dP over dt plus with 2p, sorry. Okay, 2p over 50 plus T is equal to 50 plus T square times 3. Okay, so when we choose dp over dt, no, dp over dt, actually this is d only. We want to differentiate d of p50 plus t square. So equal to 3 times 50 plus with t square. Okay, so when we integrate this, we solve, we will get p times 50 plus t square is equal to 50 plus 3 power of cube plus c, or our p is equal to 50 plus with 3 power of 3 divided by 2, so they have no power at all, so we can cancel power. Okay, then plus with c over p50 plus with t square. Go at the end for question B, we want to solve. No, not B yet. So at A, they are given, and we want to find at t equal to 0. Okay, so from here we can find at t equal to 0, p is equal to 10. So 10 is equal to 50 plus with 0 plus with c over 50 plus with 0 square. So that from here we will get our c is equal to negative 100,000. Okay, then from here we will get our a is equal to 50 plus t, okay, minus with 100,000 over 50 plus t square. Okay, then we will get volume is equal to 100 plus with 2t and 250 gallons we have here. So 250 is equal to 100 plus 2t, and we will get here our t is equal to 75 minutes. Okay, we try example 3. So a tank initially contains of 60 liter of solution. Okay, let we highlight all the information given, in which 0.5 kg of salt has been dissolved. Beans containing 1 kg of salt per liter enters the tank at 2 liters per minute. And the perfectly mixed solution leaves the tank at 3 liters per minute. Find the amount of salt in the tank after t minutes. So as usual, so the first one, we try to find the a over dt first. Okay, so it's equal to R in minus with R out. So dA over dt is equal to 2 minus with 3a over 60 minus with t. Okay, then from here we will get the a over dt plus with 3a over 60 minus t equal to 2. So by using IF here, we integrate can e power of integration of 3 over 60 minus t dt. Okay, we will get e power of negative 3 ln 60 minus t, or we can cancel learn. So what left is 60 minus t power of negative 3 only. So negative 3 here. Okay, then we want to solve for 60 minus with t times power of negative 3 times dA over dt plus with 3a over 60 minus t is equal to 60 minus t power of 3 times with 12. Sorry, not time with 12, time with 2 only. Times with 2. So we divide by the 60 minus 30 here, we will get dA over dt P 60 minus with t power of negative 3. So equal to 2 times 60 minus t power of negative 3. Then we integrate both sides. Integration of this both sides. We will get at the end a times with 60 minus t power of negative 3 is equal to 2 times with 60 minus t times with negative 3. Then we solve, we will get a 60 minus t power of negative 3 is equal to negative 2. 60 minus t power of negative 2 over negative 2 plus with c. Okay, then we solve at t is equal to 0, a equal to 0.05. Okay, so 0.5. Sorry, not 0.05, actually 0.5 only. Okay, so this is 0.5, so 0.5. So 0.5 equal to 60 plus with c over 60 times negative power of negative 3. Then we will get our c is equal to negative 595. Okay, sorry, 595. 595 over 60 power of negative 3, which is we will get our a is equal to 60 minus t for ut minus with 955. Sorry, 955. Not 955. This is actually is equal to 595 over 60 power of 3 times with 60 minus 1 power of negative 3. So this one you can try by your own.